Hello everyone, my name is Cavell, and today I am going to be talking about exponents. To be more precise, I will be talking about negative exponents and the rules when it comes to multiplying variables of the same base with different exponential powers and dividing. So first thing I want to talk about, like I said, is negative exponents. So let's start. So negative exponents. So, when we think of exponents, we need to provide an example. So, for example, let's have 3 to the negative 2. So, before we even talk about negative exponents, something you want to understand in math is that a lot of the principles in math stem from a recognition of patterns. So, if we think about the number 3, the base 3, right? 3 to the first power is what? That's just 3, right? Now, if we think about 3 squared, what does that mean? Exponent 2 right here tells us how many times this base is multiplying by itself. So, if there's a 2, that means it's telling us, okay, we need 3 to be multiplied by itself twice. Hence, we get 3 times 3. Let's do another example. If you get 3 to the third, the exponent is 3. The base is 3, so therefore we have the number 3 multiplied by itself 3 times. So we'll have 3 times 3 times 3. One more. Let's say if we keep on going further, we'll get 3 to the fourth. Once again, the exponent is 4, base is still 3. That means 3 is multiplied by itself 4 times. So we'll have 3 times 3 times 3 times 3. As you can see, the exponent tells us how many 3's we should see when we're multiplying them all together. So here we see 1, 1, 3. Here we have 2, right? 2. This is just 1. Here we have 1, 2, 3. 3. Here we have 4. 1, 2, 3, 4. So like I said before, math is about recognizing patterns. And as you can see, each time we're going an exponent higher, we're multiplying it 3 one more time. So if we keep on going, it increases. Increases, and we're multiplying by 3 each time. Now, if we look at 3 to the 0 power, so if going down is multiplying by 3, if we're going the opposite direction, we should be dividing by 3, right? So 3 to the 0 is 1, because 3 divided by 3 is just 1. So now here's where the negative exponents come in. Now if I have 3 to the negative 1, what do you think that would be? Well, that would be whatever the 0th power of 3 is, divided by 3. So we'll have 1 divided by 3, right? Let's see what 3 to the negative 2 is, right? The original example we had. So 3 to the negative 2. So if we can look carefully at the pattern here, we can see that as we're going down, we're multiplying by 3. And if we're going up, we are dividing by 3 each time. So here we have 3 to the 0 equals 1. Divided by 3, we get negative 1. Divided by 3 again, we get 1 over 9. But as you can tell, these are all powers of 3 still. So in other words, we can write this as 1 over 3 to the 1. For this one, it would be 1 over 3 to the second. So like I said before, math is about patterns and recognizing those patterns. So to conclude, when it comes to negative exponents, any number that's in the shape or form of a to the negative x will be 1 all over a to the x power. So let's see, what would 3 to the negative 5 be? Well, let's see, what would 3 to the negative 3 be, right? So 3 to the negative 3 would be just 1 over 9 divided by 3, or in other words, 1 over 3 to the third. What would 3 to the negative 4 be? Same idea. Whatever 3 to the negative 3 is, divided by 3 again. So we'll have 1 over 3 to the 4th. So if you look at 3 to the negative 5, the pattern still goes on, right? So we divide by 3 again, and we'll get 3 to the negative 5 is equal to 1 over 3 to the 5th. So that's how negative exponents work. Now, let's talk about variables, same variables, to different powers of exponents, or different exponents. Well, now let's talk about same variables to different powers. So, we have rules in regards to exponents where a to the b times a to the c is equal to a b plus c. So you're probably asking, Cavell, I mean, math is really hard, and I do not want to just memorize things that I don't understand. Why is it that a to the b times a to the c is equal to a to the b plus c? Very good question. So let's do a few examples and see why that is. So let's just say we have x to the third multiply by x to the square. According to the exponential rule, when we're multiplying same bases with different exponents, we add them together. So this should be x to the 5th. But you're still asking me, hey, Cavell, you haven't really explained anything. So here it goes. This is going to hopefully help you understand why this rule works. So let's break this down. X to the cubed. What does that mean? That means x is being multiplied by itself 3 times. So instead of writing it with exponent, let's write it out completely. Let's expand this. So x to the cube is the same thing as saying x times x times x 3 times. Now let's look at x squared. How do we expand out the form of x squared? Well, that's the same thing as saying x times x. How many times? 2 times. Now, if we look at this, we can see that these are all being multiplied each other, right? So this right here is actually x cubed. This right here is actually x squared. And if we multiply them together, that's the same thing as saying this, right? X times x times. So x times x times x times x times x. How many x's are there? There's 5 x's. So what's our answer? So if there are 5 x's all multiplying by each other, we get x to the 5th. X to the 5th. And that is why when you are multiplying variables with the same, or terms of the same base and different exponents, you add them together. And what I just did proves that, right? So x cubed is just x times x times x. X squared is just x times x. And if we're multiplying x cubed by x squared, we're multiplying this stuff right here, right? This stuff right here, x cubed by x squared, and we get x to the 5th. That is why a to the b times a to the c equals a to the b plus c. So in math, it's good to have a little sanity check, meaning you want to do some more examples. You want to see, does this really work? Does it? Does it really work? So let's do this again. Let's say we have a squared multiplied by a to the 4th. Now let's expand this out. So a squared is just a times a. I forgot to mention, but the parentheses are to denote multiplication. So this is just a squared. Now let's write out a to the 4th. That's a times a times a times a 4 times. Hence a to the 4th. And now if we count how many a's there are, how many a's are there? There's 1, 2, 3, 4, 5, and 6. So that means a squared times a to the 4th is just a to the 6th. So if we look back at the rule again, a to the b times a to the c is equal to a to the b plus c. So when we are multiplying terms of same bases and different exponents, we simply add the exponents together to get the answer. So you're all asking me, okay, we've done it with variables, but I really want to make sure this is correct by using non-variables. So hey, let's do it with actual numbers. Let's do 2 to the 3rd times 2 to the 2nd. Oh, so here you go. Let me just write that better. Okay, same idea. 2 to the 3rd is written out as 2 times 2 times 2. This is 2 to the 3rd. 2 to the 2nd is 2 times 2. This is 2 to the 2nd. How many 2's do we see? We see 5 2's, so 1, 2, 3, 4, and 5. So 2 to the 3rd times 2 to the 2nd is 2 to the 5th. So how do we check that? If you still don't believe me, let's do this math. So what's 2 to the 3rd? 2 to the 3rd is equal to 8. 2 to the 2nd is equal to 4. So 2 to the 3rd times 2 to the 2nd is the same thing as saying 8 times 4. 8 times 4 equals 32. So what's 2 to the 5th? So let's do this. 2 times 2 is 4. Times 2 again is 8. Times 2 again is 16. Times 2 again is 32. These are actually the same, which means the answer we got is actually correct. And that is why the property of exponents or adding exponents works. Alright, now I will be talking about the rule of dividing terms with the same bases and different exponents. So, the rule I'm going to tell you, which you're going to be confused and you're going to not really believe me, but I will definitely explain it. So, the rule goes a to the b divided by a to the c is equal to a to the b minus c. So, why is this true? Well, I'll show you. Let's do an example. So if we have a to the cubed minus a squared, according to this rule, I should have b minus c, in other words, 3 minus 2, or a to the third divided by a to the second is a to the 3 minus 2, or in other words, this should be a to the 1, or just a. So, to show you why this is true, we should expand out a cubed and a squared. So, a cubed is the same thing as saying a times a times a. What's a squared? A squared is just a times a. So now if we look at the numerator and the denominator, we can see that some of these a's factor out to 1, or as some people might say, they cancel out. So let's do that. So there's an a up here, a down here, a up here, a down here, and what are we left with? We're left with just a. Wow, look at that. The formula worked, right? Let's do another example. I think in math, a good way to understand principles and certain properties, you really need to do a lot of examples and kind of convince yourself. Don't take everything you learn in math for granted. You want to see it for yourself. Same thing for me. It's kind of like a sanity check. You want to know through your own eyes, through your own experiences, that this is actually true. So let's do another example. Let's just say we have x to the 6 divided by x to the 5th. So let's do what we did before. Let's expand it out. So x to the 6 is the same thing as saying x times x times x times x 6 times x times x. So 6 of them is all divided by x to the 5th. So there should be 5 x's. 1x, 2x, 3x, 4x, 5x. Same process as before. We see that some of these x's cancel out. So let's take one at a time. Cancel, 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 and we just left with x. So according to the rule, without expanding these terms out, we can just say x to the 6th divided by x to the 5th is the same thing as x to the 6 minus 5, and which is just equal to x, which is the correct answer. So now let's do another example that might be a little trickier. So what happens if the numerator's exponent power is lower than the denominator's power? So let's just say we have x squared all over x to the 4th. So let's do the same thing. What's x squared expanded out? That's just x times x divided by x to the 4th. X to the 4th is just x times x times x times x. So we can see that these x's cancel out again. So 1, 1, 2, 2. Now we're just left with 1 over x times x, which is the same thing as x squared. And you're probably wondering, hey Cavell, according to the formula, this should be x to the negative 2, right? Because x to the a over x to the b is x to the a minus b. And I am going to say yes, that is absolutely correct. But why does it look like this? Why is it 1 over x squared? Well, that's because 1 over x squared is the same thing as x to the negative 2, right? Remember, previously I told you that whenever we have something to the negative exponent, that's the same thing as saying, so just a quick reminder, x to the negative a is the same thing as 1 over x to the a. So in other words, x to the negative 2 is the same thing as 1 over x squared. And that is why and how this exponential or this exponent property works when it comes to dividing terms of the same base with different exponents. So now I'll be talking about the exponent rule of power to a power. So the rule tells us, or the formula tells us, that a to the m to another power n is the same thing as a to the m times n power. So for example, if we have x to the third, right, raised to another power to the fourth, that's the same thing as saying x to the third times fourth. So we can put another little bracket here just to denote that, which is the same thing as saying x to the 12. So you're probably wondering why this works. So this works because if we think about what this means, so if we have x cubed, right, to the fourth power, that's essentially saying x cubed is multiplied by itself 4 times. So we have x cubed, x cubed, x cubed, and x cubed. And if you remember back to the original rule of how to multiply variables of different exponents with the same base, we add them together. So this kind of simplifies to how many x's do we have? X cubed is just x times x 3 times, right? Once again, x to the x, 3 x's. When we do this 4 times, so what do we get? So this is 1, this is another x cubed, this is a third one, and then we have one more. And then as you can see, all right, how many x's do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is x to the 12, which obviously agrees with the formula that we have written. So we could do one more example. So let's do another example up here, top right. Let's just say we have x squared to the fifth. That'll be same thing as saying x to the 2 times 5, which would just be x to the 10. So let's do with some fractional, some exponents with a fraction. Let's say we have x to the 1/2 to the 4th. So that would be same thing as x to the 1/2 multiplied by 4, which is just x to the 4 over 2, which is just saying x squared. And how do we show this? Well, if we think about x to the 1/2, that's just square root of x, right? We have that 4 times. If you look carefully, each of these things becomes just x, right? Because square root of x times square root of x is just x. So essentially, you'll just get x squared. And that is the exponential property of raising a term to another power. And that's it for today.